So I think so. You might be small part of it, but it's okay. So that's so what I'm trying to say is the basic steps. So basic steps on ATM machine. So will be but first we need to insert the card and then we need to tell the PIN and then we have to mention the amount we need to go borrow and then basically and then we have to tell. So once we mention the amount, so the ATM might ask whether it's correct or wrong, and after that they will release the money and as a last steps they will release the card. That's the process, right? So those days that when ATMs are set up in all these days, so the ATMs are very primitive. They are not AI empowered or anything like that. So they are very primitive and they can handle only one transaction, one card at a time. But so and they so what happened was in Sri Lankan countries as they has as they promoted, so people had a mindset. It's if it's you are at a rush, you can go to the or even midnight or 4 hours, you can go right to a ATM and get your money out. So what really happened was uh, so as soon as we go to the ATM and we insert the card and enter the PIN and we mention we need to borrow money, I think we mentioned 1,000 rupees and the by bank the ATM release 1,000. So as soon as we got the 1,000 rupees, so user perspective, so my workflow is completed. That's why I rush to the bank. So it's a midnight and I need money urgently and go. I went there. I get the money. But how it ended up? It ended up with as soon as release the money, the user perspective, I completed my workflow. So because of that, the person who are in front of ATM always felt like that. So he is ready to go. And most of the occasion, that's what happened. People are leaving after getting the money, but they're forgetting to getting the card out. So how ATM responds afterwards. So when person forget to get the card out, he wait few seconds, few minutes, and he kept the card inside the ATM, and ATM started getting locky. So after onwards, ATM can't operate because there's a card stuck in the machine. So they can't handle multiple cards at that time, those days. So those are very primitive ATM. So like not like that this right. So what happened was happening everywhere in the country. So all the ATMs getting started stuck in the evening because people are forgetting the card, getting card out. Okay, so that became a huge problem for every bank because now ATM are not getting promoted. The people are really worried because once get stuck, think I want get to money urgently and I went to ATM, but I can't get the money out because the ATM was stuck. Until next day bank open and clear the ATM or reset the ATM and remove the card stuck in the machine until nobody can until start the bank next day morning 8 a.m. or 9 a.m. Until then, nobody can do any transaction via ATMs because ATM are not becoming a popular because it's become a headache for people. People and even bank. So everybody start feeling this is not going to work because people are forgetting the card and hereafter no point of having ATM, right? So until next day morning, they until they clear it up, so nothing will happen. So it's become a mess in the entire country. No, none of banks are feel this is useless. The new technology seems to be useless. They can't use it in Sri Lanka. So that was the feel, right? Even people blast into the banks and they are not happy about the ATMs, right? So they still feel the old queue is good rather waiting for evening and get the money, right? So that's the feeling. So that what was the problem? So problem. So how they fix this problem? I think even some of the banks still use this new fix. How they fix is so they interchange last two options. Once you enter the amount you're going to borrow, or want to mention the amount you're going to get out from the ATM, rather releasing the money, they start releasing the card first. So then what happened? The person is will get the card, but still he didn't get the money because of that he stayed until ATM delivers the cash, right? So they swap this last two steps in the ATM work. So actually what it was, right? So basically it's a defect in this flow. So because why I'm saying it's defect, because this workflow has not tested against the Sri Lankan culture. So because of that, it's ended up with introducing a defect for the workflow and it ended up with collapsing the banking business, right? Basically banking business. The reason is this application before it released to the Sri Lanka, they just import the software from somewhere else, some other country, and they set it up here, but it never tested against the our culture. Right? So that's the fundamental breakpoint. So it has not been tested. So it's that against the Sri Lanka. It might have been tested for against some other people countries' culture, but not for us. So that's the challenge. So that software has to be tested like that, right? Not only just technically test. You have to test against your culture, right? Unless it won't be able to affect you. So that's the challenge, right? So that's a very old example, early 90s example in Sri Lankan context. So, and this is a good case study for everybody why software has to be tested, right? Okay, so that's another example why software has to be tested, right? So it has to be tested independently unless we won't be able to find out these kind of problems because developer will not feel this. This is something different feeling. So testing against a culture, right? So that's another example. Right? There are many other examples like this. So that's why we need to test softwares before we release the client. That's why we need to test softwares scientifically, and we that's why it's become engineering process as well. So it's not that became a part of our curriculum as well, right? So software testing is something very mission critical. So we can't do that. We can't avoid it. So we have to do, and it became a profession as well. So that's why software quality engineer last 22 years I was in this quality assurance industry. So that reason is quality assurance has become a crucial role for a software development industry, right? So that's the reason. Right? So any questions? Any examples you want to share? So anything you want to add? These case studies. Do you have your own case study about this? No. Okay. So let's move on then. Uh, the for I think that's very clear, right? So I'm pretty sure it's very clear. So I'm not taking much time on the introduction part. So there are many other examples. So if even I can share. Uh, yeah, beta testing is something. So basically, so it's kind of a outsourced testing, right? So thing is, if you have released before releasing any software, I think organization used to release beta version. So that means, so think once you so basically in our process, so in software development life cycle process, basically we'll start with uh, we'll start with the developer test, right? As soon as code is developed, developer has to do his developer unit, basically unit testing and developer testing. Once it's perfect, only it will be released to the quality assurance, right? For the testing. So then quality assurance engineers will test independently for it. They will do the system integration testings and non-functional functional testings be called black box. We'll look at the deep later. So they will do that. Once this QA teams are confident on testing, so they will raise for the use acceptance. So that means business users will test. So once business users will test and everything is perfect, is everybody sign off, so then it will go to the live or production. But some organization think if they are releasing a very new product like Windows, Microsoft is releasing a very great new product, or either Google is going to release something very new. So then most of the time they will not immediately release the last version. They will do a beta version. The reason is they want to capture the consumer behaviors and consumer expectations and consumer feedback or either end user feedback. So that's the reason, right? So they want to know the end user, actual people, how they are going to respond. Actually, because sometimes even whatever the surveys they have done and all those things might not perfect. So that's the reason beta version to release, and they can make sure sometimes their product, there are some other hidden agendas as well, right? Like their product is not stable, not up to standard. They want to have another set of patches going on, but they have committed to customer to come something new. Because of that, keep the market engaged. Also, they might release it. But my end goal is by doing it, they can capture all these problems that user feels freely, right? So we it kind of a crowdsourced testing. That concept has been used as a beta, right? So that's the one key reason. I think that's a good question, Praveen, right? Okay. Um, so any more questions? Anything that you want to clarify on this basic concepts perspective? Okay, let's move on then. All right. So basically, that's what I was telling you. So again, so these are few, I can't say definitions. So these are few statements about of that is because there are not clear definition on history, right? Because one reason is because we can't have definitions. That's a common problem in even entire IT industry, right? We don't have much definitions. When you look at any other like physics or chemistry or any other subjects, they have very clear definitions for everything. The reason is these subjects are evolving thousands of years. Even humankind started, right? So if you looked at medicine, engineering, construction, and all those things, they are from the human being started in this world, right? So millions of years. But IT industry only have 60, 50 years of experience and exposure, and throughout the period, it's evolving. It's nothing concrete. It's evolving. I think it's the characteristic of this industry itself is the evolving. It's fastly changing because of that no definitions always, right? So these are few thought processes. So I think the last one actually I really interested about it. So it's they say so that testing is kind of an empirical in technical investigation of product or software with identifying all the problems and information of the product related to the quality and share it with everyone, right? So all the stakeholders, everyone means all the impacted people. So basically, it's kind of a technical investigation, right? Or it's a kind of a like if you are reading a book, so it's kind of a reading application, right? Reading as application just to identify the problems related to the quality and share it with everybody. These are the problems, right? So that's basically kind of a explanation. I think that's a nice one, but I'm not much going deep on this statement. So I think I just want to share a few. So I think why software testing is important. That's what we discussed, right? And these are few examples of software defects, right? So I mentioned about the Sri Lankan example, right? So ATM, right? So there are these global example, but all these example that happened, one happened was the rocket launch in Ariane 5, and one happened is radiation therapy machine, and one happened for a gambling organization, right? And even they impacted, right? Another one is video assisted referee system, right? So even we happen for football, software defect make a problem. So even we know the even for a uh, cricket, right? So we all love to watch, right? Cricket we use even the LBW, the video reference system, right? So it's a software, right? He decide whether it's going out of the out of the wicket or in, right? Think there are some due to some defects. So incorrect judgments are coming out from this video referral system. So what might ended up with, right? It will ended up with like collapsing entire game, right? So that's very crucial, right? That's why just making sure that testing these kind of applications extremely mission critical, right? So something going wrong in this video referral system, what imagine what will happen in a World Cup tournament, right? So I think it will ended up with the even can't imagine how it will going to ended up with, right? It I'm not sure what it might be ended up with the world war sometimes, right? So so that's where we are. Right? So the technologies are very crucial and certifying these products are very important, right? Okay, I think this is a very good example I found all of a sudden. Uh, I think this is something to think about it, right? So I am not sure whether sometimes you might heard about this, right? So the thing is, so we know to rotate our world on its own axis. It took 24 hours. Right? That's a common thing we know as well as science we knew that, right? So it's 24 hours. That's the day. It's basically day is defined based on how long it will take to rotate the to its own axis. But with all human interactions and actions, and because of a lot of things, now it has been identified. Uh, it's actually not 24 hours. So scientists has been found out. So with various human activities, it has been fast now. So it actually 1 second leap. There's a leap 1 second throughout the period. So now what does it mean? So basically the what does it mean means what we the time what we have in our watches are not correct now, right? So this might impact everywhere. We don't know. This might impact for our satellites or other systems because there will be a lot of impact, right? Right now, even there might have those impacts. We don't know because of this time our calculation wrong, right? So one point, I'm pretty sure one point the scientists will decide, and we have to correct this because unless the impact will high, if we are not going to correct in our clock, so then maybe the people who govern this world, right? I don't know who, right? Maybe either China or either US, Trump, or either both will come together and decide this. Let's correct this, right? At one point, this might happen, right? So everybody will agree as a world to correct. So how they are going to correct it? Hopefully, they will maybe think they decided to correct today midnight. So probably they will by today midnight. So by 12 so they will increase 1 second, right? So they will make it as a 12.1 second. They will change the clock so that they will stop the clock by 12 and they will increase the 1 second. So something like that might happen. So if it so think they decided to do today midnight, so do you know what will happen to our softwares? So that's a crucial question, right? That we don't know. Why I'm saying don't know is because we have not evaluated, we have not tested for such a scenario. I'm pretty sure none of organization, none of software we have in this world have even think such a scenario. But that kind of scenario might happen anytime, right? So that's a crucial thing, right? So ideally, these scenarios are tested. Tell you honest, I know because I work for IBM for a longer period. So they have tested this scenario even without knowing this, right? So that's how it ended up with, right? Because of they have their globalization testing rules. So to make sure release any software, they have to test this globalization concept, validations. So unless they are not allowing any software to release for a production, so part of this globalization testing, they do this testing. If time zones are getting changed and on times are getting changed, how artificially change these times, what happened to the software? So ideally, every software has to be tested, right? Unless if such a decision comes, so we might have to all of a sudden test and verify whether applications are working, right? Unless even sometimes satellite might get collapsed to the ground, right? We don't know, right? Planes might get collapsed to the ground by doing this change, right? So that's one of mission critical, right? So that's a good example to think. So right, so I just found all of a sudden when I'm reading some articles. So that's how that's why the software testing game we need to think about mission critical. So without looking at software testing is a whole holistic move, so we won't be able to think even right now today, right? So in the current industry, testing has become a very crucial, right? Okay, so any questions further, or I just move on to different topics? We try to get some small intro still, right, for entire software testing workshop what we are going to do today. The next thing is, I think since you exposure to the software development, right? And some of them you already in the industry, so you might heard about software development models, right? Software development life cycle. So what is the most common software development life cycle? I am sure you know, right? You might have used it, you learn it. Basically, the most common software development life cycle is waterfall, right? So you might heard about this waterfall software development model is the most many people talk. But tell you honest, when you look at the industry, right, the waterfall, I think waterfall is the kind of a dead. I know there are still some organizations they might use them, but it's a dead model. Tell you honest, I when I'm starting my career in somewhere in 2003, even in 2003. So I joined the Versa 2003, and then when I'm joining the Versa, they even didn't use waterfall. They had a different model. So we will see what is waterfall, right? So what the problem with waterfall is, so we have multiple phases like requirement analysis and design, coding, testing, right? But testing comes at it. So what happened if you find out requirement defect at the last phase of testing? You have to go back to the requirement and fix it. So then you have to do analysis, design, coding, all the layers again one by one, and you have your effort to deliver such a product is can't imagine, right? Because testers are in latter part of phase and they are finding out defects in even requirement might probably they might find out. Then if we are going to fix those things, so probably you are ended up with you not releasing any product to the clients, right? So that's why the waterfall is kind of a dead model, right? So the solution given is the V model. Or some people say double V model, some people say W model. It's fine, but the concept is same. So that is the model given solution. When I started my career, so I experienced this V model at Virtua. So at that time they use it V model. That's why the software testing become a boost even for the industry, right? Because of this V model. The previous model didn't work. So what V model is every phase, business requirement, system requirement, designing, coding, every phase they introduce the testing phase. Against every phase there is a testing phase like business requirement acceptance testing, system requirement system testing, designing the integration and component testing, coding its unit testing. Right, each development layer there will be a testing layer against the development layer. So that's good, right? Because the testers will test immediately and raise the defect and make sure that the phase is perfect. But with this, it's a huge testing effort has to be introduced by for all the clients. That's why the testing has started becoming a very boost, and that's why new field has immediately boost in early 2000. So that's why even I started my career as a software tester because there are huge vacuum in testing, and they are looking for testers everywhere. So just get the job without doing much effort, right? So, so even without knowing software testing, those days we didn't know about software testing. Even we didn't, the universities never taught about testing, so we didn't know even the concepts, right? We became a tester even without knowing the concepts. The reason is so because of this, so the organization started using the BW model and huge testing vacuum is raised. So people start, right? So that's how it's so. But now, so if we looked at the current, so I think I got the answer from one of you answer agile, right? So this all these models, V model or either waterfall model, so there's a problem because clients are getting the release at the end after 2 months time, 2 years time, sometimes 3 years, 4 years time, right? So that's why the Microsoft taking many years to release OS for those days, right? So so we are for a Windows 98 to Windows XP and Windows XP to Windows something latest 2007 8. It took many years because of this waterfall model, right? They can't release anything very fast. So to fix this problem, so industry identifies the iterative model. So do a small iterative of software. Software has been divided into a very small part of the requirement divided to very small, and we will implement very small set of requirement in a one iterate and release it to client or end user, and then we'll move on to a small releases. So that's good because we people will get good feedbacks, and we if there are things, if what we are going to deliver is not perfect, then we can quickly change it and we can redo it, and a lot of advantages. So people will move to iterate. With this iterative move, so people will figure it out the agile software development model. Right? With this agile model, so the entire world started changing, right? So agile basically is kind of a collaborative development. It has only three roles. So agile teams has only three roles. That's the product owner, product uh, uh, scrum master or something like that, and rest of all come as a development, right? So development team include devs and QAs, BAs, everybody. Everybody considers a software development team, and everybody has a shared responsibility because everybody has shared responsibility of making sure they work common goal and deliver software in an iterative manner very fast. This with this shared responsibility, so people has to have work together, and small releases will be delivered, and it's a shared. And with this agile, we always there's a concept you might heard about shift left, right? So shift left is lifting our entire work to the left. Right? So that's the shift left. So in IT industry, software development industry, so use this concept in agile. They started shifting the software development process to the left and making sure early delivery with a better quality to the client. So how they shift left? So shift left is a good concept even. So even we can practice in our life, right? So that's why everybody is believing by moving to the left side of this world, people will get better. The same concept. By moving to the further left, we can bring it more fast delivery and better delivery to the software. So how they could do in agile? Yeah, that's very good question. This one is asking whether does the tester need to be thorough with the coding programming or just basic concepts? Good into I think so. I think I am coming to that point, right? Let me explain with even my next slide. Right, that's exactly the point I am going to describe. With this shift left, what right now happen in industries, right now we have new tech concepts has been introduced like test driven development, behavior driven development, like the new concepts. With them, we do we testers start their work even before start developers. So how it happening? So how testers start work early? So basically, as soon as requirements getting ready, things requirements are getting ready, the testers will start their test case writing. Then they will automate. Eh? So before even developers start their coding, testers will write the test cases, and basically we call acceptance testing. They will write acceptance testing and they will automate and they will ready with that. When developers start in their coding, I think we looked at, so when tester is complete in their test suite, there are no code developed by developers. So the first day the tester complete in the test suite, there are no code developed by. So if we run against without code, his test suite will get fail because there's no code. Right? Entire test suite will be get fail, 100% failure. The next day, maybe 10% of code has developed by developers and committed. So then what will happen? Next day, when the tester is executing his code, his automation suite, there are 10% of code has developed by developers. The 10% of test case will get passed. The second day, if 20% of code has completed, then 20% of test case getting passed. So 10th day, developer is assuming developer is completing 100% of code. At that time, testers test cases are getting fast and 100% execution he will get. That means rather doing testing at the once the developer is completed, tester will start early and do get ready with his automation suite, and with that, when developer is completing his last line of coding, we are making sure it is tested. and it is ready to deliver. So that's a shift left. The completely shift to the left side and do a delivery, right? So that's the expectation of Agile, right? So with all these expectations, Agile has changed this entire world like this. So what is exact? So previously we had different type of developers: UX, UI engineers, Java.NET engineers, DB engineers, DevOps engineers. There are many more middleware engineers, UI engineers, backend engineers, right? Many engineers. All, and similarly, there are a lot of QA roles, right? Functional engineers, automation engineers, performance engineers, security engineers, security test engineers, and many engineers. But these roles are right now merged. So all these development roles, right now we can't see DB developers or backend developers, middleware developers, front-end developers, right? All these roles up to DevOps has merged now, and now we have only one role, full stack engineer. Similarly, software testers, all these roles has been merged and they are become a software development engineer testing, SDETs. We call SDETs. Full stack engineers or SDETs. So those are the two roles right now industry is looking at, right? So those roles, so the testers perspective, those roles are not manual testers or functional testers. They should very thorough with the domain, plus they should very perfect with coding and other technical standards. Unless they can't be a tester. Right? Now the tester has to be more technical than developer unless they can't be survived. Because you can't, the complex systems that I mentioned previously, like stock exchanges, they do millions of transactions. So if you looked at the LSIG, the software that developed by MIT team, its work, it disseminate market data in nanoseconds. Can you imagine? Nanoseconds, right? How you can test such application manually? You can't do that, right? You have to do coding that coding better than the coding that used to be developed the application, right? You can't test this manually. You can't test this millions of transactions manually, right? So you have to code. Your testing will be a part of your coding, right? So that's why we need software development engineers in testing. That's to do this business, right? But these are the two key roles. If I think you since you know about the industry, you know this, I'm pretty sure. So that's industry has been changed. So so, but I think this change is even not today. This so I will show what is the latest change in latter part of the workshop, right? Maybe evening. So this change for me, it's like they changed up to yesterday. So now with the AI, this has been changed, right? So we'll see how the latest change. But right now, industry is the kind of a level like this, right? So I think that's the answer that I could give for the question that you asked. So testers should be thorough with domain knowledge. That's must. Plus, they should be very be good with the coding programming, unless they can't do this testing, right? So basically, testers are more strong than developers as this is the current world, right? Okay, so that's how it scenario in this industry, right? So that's why I want to. Okay, so that's basically the few basic intro I just want to cover, right? So coming to the main topic. So I think we can move on to the main topics. Probably a few things. So, so since the testing, how testing has been emerged and why testing is essential, that's what we discussed. With all this, so it's no negotiation. Testing has to be done, right? But what level we should do the testing? So that's the next question. Are we going to do the testing? So if you Google it, how many testing types available? So you can get a list of thousands of testing types. So are we going to do all these tests? So that's the question. Are we supposed to do all these testing tests? What do you think? So think you have given an application to test. So someone developed by maybe banking application or something like that, mobile app or something like mobile internet banking app or something like that. So which testing types you are going to do? If you Google it or if you use ChatGPT, he will tell. So if you want to, so you can put your prompt and you can ask how what are the testing types I should use for an internet banking mobile app. He will give the hundreds of testing types you should do. What do you think? You can you? So the one answer I got is happy path testing. Yes, but part of answer, but I can't say yes. Let's see. So what? So basically, so if you looked at testing types, there are two different testing types again, right? So we'll come to the answer of the question I asked. So, but before that, so there are two different type of testing types. Right? So basically, functional and non-functional. The functional basically is what is your requirement of your application and what functions it implemented, something like that. So that's a function. What part of software? So non-functional is well part of it. How well application work for a 10,000 concurrent users? How well application work? The hacker is going to hack your application, right? How well it is going to work for a different browsers or different mobile devices? So how well? So these are basically the first part is functional is we are going to validate how we are going to what requirement is implemented. Second one is more it's not quantifiable, right? So basically, if you are going to state about a person, right? So we can say he's a tall, he's fair, he's fat, or he's something. He's wearing usually trousers and denim, or he's usually denim, something like that. But that's a functionality of him, right? But non-functional is what's his attitude said. He's a genuine. He's his attitude part of we that we can't measure, right? We can't tell it by looking at. To measure that, we have to do a long process, right? So then only we know he's a kind of a genuine person or he's a kind of a different person, right? So it take time. So that's a different type of testing, right? So if you looked at different testing times, you can see. So you functionalist unit integration, smoke, and all these globalization, localization, all these. The performance, endurance, load, security, scalability, all this comes as non-functional. So that's difficult. Right? So, but problem is, so how we are going to define? So, in addition to that, there are another type of testing we call change-related testing. That again, change-related means if your application has bugs, once it fix it, you have to retest these bugs. Right? We call confirmation test. We are just retesting your defect. But in addition to that, you have to do all the impacted areas. You have to test all the impact areas due to bug fix that we call regression. So there is another type of testing. But how you can decide these all different type of testings? So what's the way of identifying? So which testing types you need to do? So even you ask for a chat GTP, he will do hundreds of testing types. The problem is you probably will not have enough time to do all this testing, and even nobody will happy to give this much of effort time because it's again money, right? And it needs money. So how we are going to decide this? That's the challenge, right? That's what we need to think. Okay. So in general, there's a concept called risk management. Right? So have you heard about risk management? This is a generic concept you can use in your life or wherever you go. It's not related to software engineering. What is a risk? So before managing the risk, we should know risk, right? What's the risk? Well, I have a very good risk management case these days. So I'll tell you. So risk is something might happen in future. Some problem. Actually, it's not happen. Something might happen in future. So in our lives, we identify that this might happen and this might not happen. So one good example is right now this BYD people has faced, right? So what's the problem, right? So actually it's not a risk now, it's a problem. But if we have think previously, So to import the BYDs, they figure it out. So because of the reduce the tax, they ask the vendor to restrict the motor capacity, right? To a certain limit. But at that time they should feel it, right? So somebody escalated and government decided to investigate it. So what might happen? So that's a question. That's a risk. So if they decided to reduce this capacity by a software, not physically, not by a software, that's okay. People will accept. But if in case some escalation happen, what might happen? They should think it, right? If they have think through, then they should have a plan at that time. Unfortunately they haven't think, because that's why now everybody is struggling. Yeah? Even government is struggling, even the import is struggling, even the people guys who purchase people are who are struggling, right? Because nobody has think through if such scenario happen. So we have mentioned clearly this is a capacity physically, but if somebody change the capacity via a software, what is going to happen? Never has been think through. That ideally this is a risk. They might think when defining the government, government defining the rule, they should think through. When the vendor is importing the vehicle, they should think through. But unfortunately, nobody has think this risk, right? So that's the finally ended up in this problem, right? So ideally, so if in real world these are risks, we should identify. Where application, so in software perspective, we should think, if I am going to develop application, at what point that application can be fail in future? We need to think about it. That's the risk. Then we can list down all those risks. Okay, this application go wrong when log into the multiple concurrent users. This application might get wrong when people are trying to access from various phones. There are many very different phones, normally not Samsung and iOS. There are many Indian and Chinese brands of phones, right? When people start accessing this from the various phones, how it going to impact? Or if somebody going to crack it, so what will impact? So is somebody going to, or whether it's going, if that software going to integrate with the payment gateway or Lanka Pay or GoPay or something like that, whether it will work or not. All those things we have to think, right? So whether it's going to fail or not. So when you can list down all these are risks, basically might happen, right? If you can list down all those risks, then you can categorize exposure of this. What is the exposure if a risk? Basically, risk has two factors. One is criticality, one is occurrence. Criticality is how much critical this if risk actually appeared in the system. So we can assume what will happen concurrent. There will be 100,000 concurrent users accessing this application. We don't know what will happen. That's a risk. Then we can assume this is a very crucial risk, right? If the application got stuck because of 1,000 user access, then people will not going to start using it, because there are many people will start as access application in a concurrent. So that's the criticality, high, whether it's high, whether it's medium, whether it's low, that we need to identify. So next thing is exposure, occurrence, basically occurrence. How far this will occur? It's very rare. There are some risks. Its risk is very high, but it occur very rare. It might never occur. So this BYD scenario, they might have think. Usually in Sri Lankan context, anytime it might happen, because people will people will raise these kind of questions, right? People are always are looking for problems, right? So because of that, in our mindset is set to raise this kind of problems. So this openly might happen, right? So that's occurrence we need. So the risk exposure is criticality and occurrence we have to multiply together and get the number. If it is highest number, it's the highest risk that might occur in real world. If the number is very low, we can say it's a least risk, it might not happen in real world. So based on these numbers, we can decide what are the highest and medium critical risks that we need to mitigate. Every risk has to be mitigated. So what is mitigate? You should have a plan to mitigate, right? Basically, if you identify the risk, you should have a plan. software can access by 100,000, I mean, concurrent users. And because of that, it might get stuck. Then risk is critical because it might happen. There are millions of users. And if it is stuck, people start blaming and not um, escalating it, and it will be a critical problem. Because of that, it's very crucial. So then you should have a mitigation plan. Avoid this, right? Your mitigation, testing perspective mitigation is do a performance testing prior to release this application and make sure application is working for 1,000 concurrent users. That's your mitigation. So your mitigation always comes as a testing type. Do a performance test and make sure application is perfect. So hackers can maybe hack this application and steal the money. So then you need to do that the risk is high. Then you need to do the vulnerability assessment, security testing prior to release the application. Or you are going to integrate with payment gateways like Lanka Pay, GovPay, or Visa, Master, something payment. So you are integrating with third-party applications, right? So then you need to do integration testing before you release the application. Think you need to translate your application into Sinhala, English, Tamil, all three languages, right? It's a government mandatory. If it's a government app, definitely you have to have the all three languages, right? So it's by constitution, it's mandate, right? Think your translations are not correct, then people will go courts, right? And government will be in trouble, right? So then before releasing, that's a very crucial risk. You need to make sure your translatability is perfect. That's we call localization testing. You have to do the localization testing, making sure your translations are working perfectly in each language. Based on your risk, you have a different testing types. So that's how you can identify testing types based on your risk. How application can break, how your application can go fail in future. Based on that, you can quickly identify these testing types, right? And you can do the uh, you can identify what are the best set of tests that you're supposed to do using the risk management concept. So that's the one way of identifying minimum number of tests that you need to perform or optimum number of tests that you need to perform to making sure application is perfect. So risk-based testing, we call risk-based testing. That's a concept, right? So we can use risk-based testing concept as a part of our strategy and identify what are the optimum number of testing methods, testing types that you need to follow, rather doing all the testing that ChatGPT suggests, right? Right? Or Google suggests. Right? So this is a concept that we use in industry. Many organizations they use as a concept risk-based testing. It's helped us to have the minimum number of optimum number of test tools types that we supposed to. If you have done risk-based testing, at least you can make sure you are releasing application with a better quality, right? So in Sri Lankan context, I have a very good example. So I think I'm pretty sure you sometimes back we had a fuel app, right? So fuel pass app, right? So when it released, there are a lot of bugs, right? People can't register their applications, right? Basically, they are vehicles. So if I give my CC number and vehicle number, it will appear someone else vehicle number, right? So if I try to ask for OTP, it never comes. OTP comes day or three later. So if I'm trying to access it from various browsers or devices, sometimes it's not work. So why all this? So they haven't think through risk concept and do the risk-based testing. So if you have done the risk-based testing at the very beginning, they will realize because there were 5 million users of the vehicles in this country. So 5 million users will going to access this application, right? So that's a critical risk. So there will be a 5 million users going to access whether this application can as tested for a 5 million access. I think they haven't think through that risk. Because of that, they haven't tested. That's why it's ended up with if I enter my vehicle number, My chassis number of my vehicle, I got a different people vehicle number. And other thing is, from where these vehicle number, chassis numbers are they are taken? From their own app? No, right? These vehicle numbers and chassis numbers are stored in RME database, right? Motor Department database, right? That database is never implemented to do these kinds of 5 million access real time, right? It's just a small DB that they store this information. All of a sudden, this DB, via probably maybe set of APIs, has been exposed to the whole pass app. There are 5 million users are going to access, right? That integration never going to happen because that DB is never ready to give this much of fast data, right? So that's a risk, right? The integration is a risk. So the ideal, if they have think through this risk, then they have tested this application to integration testing, and they might make it sure that is work. And even OTP, if they have think through whether the OTP can provide like telecom dialog OTP provider can provide OTPs this much of fast or cannot. If the multi 5 million people are going to access, they might think in even the 5 million users going to fuel every week, and database supposed to upgrade 5 by 5 million records every week. So that means for a month after there will be 20 million data records, right? Imagine how much of large database, right? So if that means that database going to stuck, obviously, right? So they never thought of it. That's why people are unable to generate QR code and a lot of problems happen. The reason is, if you have simply think about risk-based testing concept and identified all the risks and figure it out the exact testing types they have to perform, and if they have performed before really go live, these problems will not appear. Then this blame for a government will not appear. Right? So that's problem. So that's one of good case study internally we saw. So without doing a proper testing and proper test types identifying, and if you release a software, this is how it will end up. To identify, I think minimum number of tests is a risk. There's a concept of risk management. By doing that, you can do a risk management. Yeah? So I think I am not doing any group exercise at this point, but I just share some small thing that you can think about. This is about taxi booking application. I think you can do it offline, right? Since we are doing virtual sessions, so I'm not taking your time for this. Right? I will share this separately and you can try it your own, right? Okay. So next question, right? So previous question I'm trying to answer was what are the different testing types available and how we are going to identify optimum number of testing types for a project, for an application. So I think we find out, right? So we do a risk-based analysis, we find out the highest risk, and we find out testing types as a mitigation plan. So now we decided what are the testing. So we decided to do functional testing, performance testing, security testing, cross-browser testing, something like that, mobile device testing, something like this set of testing types. Then you have to write your test case for your test. So then only you can automate, right? First, you should have a test cases. So think for a functional testing, again, you can write millions of test cases, right? If you want. But you need to think what are the optimum number of test cases you can write based on the time availability and making sure application perfectly test. There's example actually. There's example I observed in my life as well. So because all of a sudden in one point I think more than 10 years ago. So I have been asked to go to a project and see whether how this project is going on because they have the organization leadership has identified this project is kind of a port vendor. It's not going well. So as a senior person, they have asked me to go and work with team and see what is happening. So I went there and I started working with the team. I talked to the team and I started discussing with the leads of the team. And I asked the first five questions. So they are in the process of executing test cases. So test execution phase. They were at execution phase. Actually, application go live within the next 2 weeks. Go to the UAT within next 2 weeks time or something like that. So they just have 2 3 weeks to go live. Test is supposed to complete and go live. But there are large number of defects they have raised, and but testing also not completed. So I just checked. So they were executing, I think, last more than a month now. Test cases, right? More than 1.5 months or 2 months. So I asked them how many test cases they have written and how many executed so far. So they didn't have single answer, but the different teams has tried different test cases, and I calculated all the test cases written by different teams. So almost 90,000 test cases, right? So when I'm asking the question how much you completed, it's about 30,000 or something like that. They have executed. So how they have executed is working late nights, weekends, continuous last 3 months. They have written these test cases and they are now executing it. But just few weeks to complete, but only 30% of testing has been completed. So I asked whether you can complete remaining by at least within a 1 week time, because they have to get it fixed and they have to do the regression execution and they have many things to complete. They can't imagine even complete. So basically this project ended up with executing only 45,000 test cases. 90 test cases has 90,000 has been written, but they didn't have time. So it's utter failure, right? So ideally at the time of writing we should feel it. We never should be able to execute such amount of test case ever, right? But unfortunately this team little bit matured and they haven't failed that time. So they have ended up with writing 90,000 test cases and they were even executing it, but without even imagining and working 24/7. So that's how usual industry, IT industry get through it, right? And people are working 24/7 and losing lives even, right? So, uh, how should avoid this? Theoretically, these 90,000 test cases are valid. I am not saying it's no one, those are invalid. Those are valid test cases based on the requirement. They have to test. But problem is whether we can test such number of test cases. What do you think? Whether we can write or we can develop such amount of test cases. So basically we can't, right? We can't test everything. Okay, similarly previous testing types. Similarly we can't do all the testing types. Even once we identified certain number of testing types, we can't test everything. We can't write 90,000, 100,000 kind of test cases because we don't have enough time, we don't have enough people, we don't have enough money to do such things. So then we need to identify the minimum number of test cases that require. So that's how we could do that. Any thoughts? How to identify the minimum number of test cases and develop? Any thoughts? Any answers? Yes, we have to go through the flow. So we have to go through the use case and identify the flow. We can identify the happy path as previous someone mentioned. So we can identify the core function first, correct? So we can execute against the priority. Yes, obviously, I think that's a fundamental failure the team that have done. So when I'm questioning, they have the right 90,000 test cases. I ask whether you have executed high priority test case first. No, they have executed everything: high, low, medium, all the test cases. That's how they have completed 30,000. And ideally, they have completed high. Even they wrote 90,000, they have completed first high test cases. So that's a one way of doing it. But my so case is how to do that testing. So there are concepts called design techniques. So even we are writing coding, we have design techniques, right? Even we are developing code, we have a design techniques. We have to use design techniques. Similarly, testing also we have test design techniques. We have to use design techniques, and we need to make sure minimum number of test cases are in. So basically, we have key design test cases. So let me show that first. I'm coming. These are the five common, very straightforward design techniques. We call equivalence partitioning, boundary value analysis, state transition diagrams, decision table, like this. Right? We'll go that deep. So equivalent partitioning means we can partition for a software based for an equal scenario. So think in your application, think it's a uh, internet banking application based on the age, the interest. If you are going to raise a count, right, a fixed deposit or something like that, based on your age, the interest will change. Think if you are a junior, right? If you are that means if you are below 12 years, so you will have a kids account, right? Your interest will be maybe 10%. But if you're adult, so in between 12 to 60, your interest rate will be 7%. It's a lower, right? But if you're a senior citizen, if you're above 60, your interest will be 15%. Maybe say based on some government rules, enforce some rules, the banks might change these rates, right? Other than in addition to the market rates, right? Market rate will be 7%, but for the juniors they will give 10%, and seniors they will give 15%, something like that. So So in your when you are raising your online banking and we are creating your fixed deposit, you might have to enter your age, right? Or the base why they enter, or either they will find out based on your ID or something. So based on the your age, they will give the different percentage. Your age is below 12, you will get 10% interest. You are in between 12 to 60, you will get 7%, and above 60, you will get 15%. So basically, if we assume we have people with 0 to 120 years of age, the lowest one is 0 and highest one is 120. So how many test cases you need to write to test such scenario? There are people in this country from 0 to 120. Then you have to test for a 0 to 120. Right? You have to test for a 0, you have to test for a 1, you have to test for a 2, you have to test for 3, 60, 70, 80, 90, 120. So we have 121 scenarios, test cases. If you are going to test, theoretically you have to write 121 test cases. But this concept called equivalent partition design techniques saying you no need to do. You just test one for a one partition. So that means below 12, take a one value and test. Maybe 10. Test it for 10. In between 12 to 60, take a one value, maybe it's 30, and test for that. And above 60, take a one value, maybe 65, 70, test, have a one test. That's sufficient. That's the technique says. So rather writing 120 test cases, you can write three test cases and making sure perfectly tested. So that's the technique says, right? So if you can use such a techniques, you can reduce 121 to three test cases. Ideally, if such technique has used for a previous 90,000 scenario, what I mentioned, definitely it will ended up with some small number, right? Unfortunately, they haven't used it. So because of their maturity level that had they had at that time, they didn't know the techniques. Right. So other technique is boundary value analysis. So in my previous example itself has about basically two boundaries. What is the one boundary? Age 12. Other boundary is age 60. So if we have such a boundary, even if you want to test, you can cover the boundary by testing 0 to 120, right? You will cover in the bound. But if such boundaries are there, don't test 0 to 120. What they are saying is test only the bound. So how to test boundary? You just have to test for a n minus 1 and n plus 1. For a 12, age 12, what is the n? N is 12. What is n minus 1? 11. N plus 1 is 30. We have to test for 11, 12, and 30. And for age 60, what is n? N is 60. What is n minus 1? 59. N plus 1 is 61. So you have to test for a 59, 60, 61. So that's sufficient. Only 6 test cases. Rather testing it for a 121, you can select 6 test cases. So that's the boundary value analysis, right? State transition diagram is something again similar. So if there are state transition, different states are there. If I take it ATM card example, as I mentioned very previously, so different states. As soon as you enter the card get accepted or card get rejected. Because if you have put a invalid card, rather putting a bank card, you put a own card. So it will reject, right? So if once you enter the PIN, either it accept or either it reject, right? So once you transaction, you can go with the transaction or you can cancel the transaction and go. Every phase there are two ways, two states. Either go proceed or either cancel or either reject. So if there are such scenarios, rather writing many test cases, you can draw a state transition diagram like this, and you can identify few testing. So only you have one testing path for the happy part. So somebody said we should test happy part. But ideally, we should not only limit happy path, we have to test other path. But you can find the optimum number of paths. This is one part, one test case. This is other part, two test case. This is other part, three, four, five. So only 5 test cases. So happy path is not sufficient. So the question that someone has mentioned, so why don't we test only happy? Happy path not sufficient because there are other paths as well, right? So basically happy path is going this path, right? Rather going with this path, you have to happy path is this, right? Rather going with this path, you have to do other paths as well, right? These are the path. So basically, we have to test for this. But doing stress transition, rather doing multiple test cases, thousands of testing times, you can identify minimum. How many? 1, 2, 3, 4, 5. Just 5. So that's how you can do that, right? Okay. So this is one other. The other technique is decision table. You can write decision table some scenarios like login page, right? If you in a login page, you can enter username, password, and login. You can enter correct username, password, enter. You can enter correct username, old password, try to log in. It will fail. You can enter incorrect username, correct password, try to log in. It will fail. You can enter both incorrect password username. You can try fail. You can enter both correct, incorrect usernames and fail. And even if you are entering incorrect, the first time it will get failed, second time it will get failed, third time it might get locked. Right? So that's how the login behavior, right? Based on the definition, right? If it is maybe 3 times or 4 times, 5 times, once you exceed that time, it will get locked. So you can just write a rules like this. What will happen? Correct username, password, and correct, sorry, both incorrect passwords and one correct password and one false password. And you correct user, sorry, incorrect username, correct password, but it's both correct. So you can define the decision table like this and find out all the combinations and you can do the test. So this will find out the limited number of test cases that you need. Here only 4 test cases. Rather writing multiple test cases, you can do The minimum number of test cases we use is the decision. That's another technique. So other technique is error guessing. So that's basically not a technique itself, but it's just a guess. How you can guess? Every scenario, there should be a negative path that will pop up with this error. You have to guess that. And you can identify all these negative paths. By doing the error guess, you can identify all the negative path you have to test. Right? So that's, but it's not a scientific way, but just guess. And based on your experience, you can do that. By doing this testing design techniques, you can identify all the required testing types. Right? So all required test cases. So that's the way we can identify uh, test cases, right? So any questions? So, but there are many uh, uh, advanced techniques like pairwise. Sometimes you might heard about pairwise testing, right? So pairwise testing is rather, so if there is a large number of combinations, think um, so if you are going to test some leasing formula, so then based on the car types, based on the vehicle color types, based on the number of engine size, based on the tire size, and all these things, their numbers will get changed. So if you are going to do large number of combinations, so you have to multiply and you can get the large test cases, right? So if first column if we have three column values, the second column we have three values, again third column we have two values, fourth column we have five values. You can multiply all together, three, two into five, and you will get all the test cases. But pair-based testing is rather doing this. He will pair these different types as a pair. Two will take together and they will identify pair and he figure it out the minimum number of test cases. That's a concept to identify minimum number of test cases that we need to test. Okay. So I think that we'll answer that. So that's a part of test execution, right? But I think we'll answer this question. So the question is, so I have seen that test case may pass when locally tested, but when deployed it fails. That's why. What's the reason? Right? We will discuss. Right. So that's the next topic I'm going to. Before I'm going to that topic, so there are different testing types, right? Basically, there are three different testing types that we call black box, white box, white box, black box, and gray box. So white box is what developers are doing, unit testing, right? By looking at the code, we do the testing. Gray box is what quality assurance people will do, right? Based on the based on the without looking at the code, based on the requirement, we do the testing. We are not looking at the code, right? We are normally we are not seeing the code. So the QA is always black box. So white box is developer testing or unit testing. So other one is gray box. So gray box basically sometimes QA and dev both will do. Basically they have little exposure to the code. Think some level of API testing or kind of thing. We need to have some sort of code level exposure, but not purely on the code. But we need to know requirement plus code both, right? So if that's the case, especially API testing, when they are doing, we need to know the requirement plus code, domain plus code, right? So then these kind of testing we call gray box. That basically either developers or QS will. The last one is experience based testing. We call exploratory testing. I think that's a one of very good one right now. People are thinking because we are automating all the possible test cases right now. So exploratory testing is the something we expect people to do to improve their product quality because by looking by that the experience people has to do. So the juniors or people you can't do that. If there is an experienced person on this domain, he can test exploratory testing and find out further defects. Right? So basically, these are the testing types. So basically, what we discuss is black box testing techniques, right? This equivalence, boundary, state transition, decision, error guesses are these testing types, right? So that's what I discuss. I'll come to the other point. So there are another way of doing is a pairwise plus mind maps. If you can use the mind map, that's also a testing technique people will use. Right? Mind map is graphically represent your test scenarios like this and find out your test scenario. That's also one way of doing testing. This also some kind of testing techniques. Okay, so I'm not doing the exercise again now here. So so then come the test execution. I think that is the problem that mentioned. So why we so okay. So once we write the test cases, so now initially we figure it out why we need to do test, right? So because of that, we come to identify test types. So we identify test types, then we identify the minimum number of test cases. Once you identify test cases, that's where your most important point coming in. You have to execute. What is the objective of this whole exercise? Identify defects, right? As I mentioned previously, software has defects because it's developed by people. The tester's responsibility or software QA engineer's primary responsibility is making sure they find out all the defects. Right? So that's impossible. Nobody can find out all the defects. So there's no way, there's no scientific way to find out all the defects because why I'm saying is so defects are little different. So defects are not physically available most of the time, right? Um, so especially this with the AI and ML, some defects are related to the data. So they are not related to code even. So because of that, sometimes defects are not related purely based on code. That's because of behavior, people's behavior, as I mentioned, the culture. Right? Culture also impacted, right? So because of all these problems, we can't find out all the defects, but ideally we need to find out as much as possible. Right? So that's the objective. Right? So if somebody is saying the QA can find out all the defects in this world, never happened. Reason is defects not only generated from the code, right? Reason is defects are generated based on the machine learning concepts, AI concepts, data, many other aspects, human concepts, all these impacted. Because of that, nobody can find out. Because something will never happen in previously and will occur this time only. So because of that, it's not feasible to write. But science helps QA engineers to identify as much as possible defects. So, but science is evolving daily, and the number of defects that we can increase, that we can identify, are getting increased, right? So that's what happening, right? So, so what's the key objective is the identify defects. So basically, the one good example is I think so we know if it is a war, right? So we can get enemies head by various ways, right? We can use a we can fire a multi-barrel get a rocket launch and fire over an entire area, kill all the people, vanish all the buildings, and get few people. That's what happening in Gaza, right? So Israel is firing all these missiles and vanishing entire human being and trying to get a capture, kill the whatever the people they want. That's one way, right? So that's even we use sometimes back whether correct or not. That's a challenge. That's a way. Similarly, you can have a machine gun and go there and find out set of people and kill them and get enemy also out. That's another way. The third way, you can have a sniper and you very well plan and go the correct location and get the exact enemy's head. Similarly, testing also can be done like this. You can write 90,000 test cases as my previous case, like a fire multi-barrel robots, and kill entire phase, everybody by killing everybody and get losing everybody's lives and get the defects out. Or you can have maybe 20,000 test cases like machine gun and get more people and get at least defects also fine. Or either you have a snipe. You write 10 test cases and capture 10 defects. So that's how you are valid. If you are a great tester, you can write minimum number of test cases and maximum number of defects. Every test case has a defect. You are a great guy, right? But ideally, you can't do that. But industry expect at least 10% of test cases should have defects. Your 10% of test cases don't have defects. That means your test cases are not optimal, accurate, valuable. Right? If you write 100 test cases, execute 100 test cases, at least 10 defects, you should be able to find out based on the industry expectation, industry best values. That's the industry average value, not the best value, average value. Right? So the now question is, so how some these defects are not appearing when the so developers are saying, I always hearing the code is working in my machine, but it's not working in the test environment or the other staging environment. Why is that? Reason is his developer environment, he has his own development configurations he has done to do the development, right? He deployed the code, he has other reference materials, maybe data, maybe integrations, or maybe other points that required to run his code. But tester or staging environment or UAT environment is not the developer environment. The code has taken out, compiled, and deployed independently. So when we doing that, if there are some independency which is available in the developer's machine has not incorporated into the development deployment, then what we are going to deploy is not correct, right? Because of that, some code that works in developer machine, it will not work in testers environment or staging environment or UAT. The reason is developer's machine, he might have his own other dependencies set. Ideally, the code that supposed to release either include all these dependencies as a one single file or one single code, or it should run without dependence, right? So if it is not running without dependencies, then he have to bundle all the dependencies and release. But that is one of fundamental failure happen most of the time. Developer they really they are whenever the code when his machine it is working and independent when we are deploying it independently in a third machine, third party machine or staging environment or UAT environment or QA environment, it is not working because then dependencies are not there. That's the reason. So that's a must. That's we have to do. These testing has to be done. Developer has to test. That's what we call unit testing or developer testing. Developer testing without doing developer testing, QA should not accept any code. But the perspectives are different. So developer testing perspective is whether code is working fine. Tester is not going to do that whether code is going to work. Tester is going to check whether requirement is achieved, right? So he tests his test cases are based out of requirement, not looked at a product or code. So because of that, both developer testing and testers, QA engineers test cases are independent and they have to execute independent. Has to be happen both, not only two times. Ideally, there should be three times of testing layers. One testing layer is unit testing. Developer himself has to do that. Then is independent testing that QA engineers has to be done. That based on the requirement. Third one is UAT, user acceptance testing. That business user has to do testing. Business has to accept. That three different perspectives. First two are technical testing. Third one is business testing. Developer is doing the technical testing based on his code by looking at his code, writing unit tests. But now it's easy, right? Then now I don't think any of developers are writing unit test cases manually. We have a lot of AI tools. So it can be auto-generated, right? Just expose the code and generate all the unit tests can make sure your code is perfect. Even QA now do not doing the test case writing or anything. They can use many different AI tools. So that's very easy and they can do, but different perspective. They check against the requirement, developer check against the code, and business check against the business, not the requirement. Right? So these three different type of testing has to be happening. And basically, objective of all these people is identify defects, right? Even developer do this testing is to identify defects. QA do this testing is to identify defects. Business do the business user testing is identify defects. Defects are the crucial. And defects uh, has various, basically three different type, two different criteria. One is severity, another is priority. Severity is whether how much of criticality that defects functional perspective. So if it is a defect that system has shut down, this crashes as a showstopper, we call critical defect. But if defect has a major functionality block, the subsection is blocked, we call major. But if it's have a minor, if then we'll call a medium defect or minor defect. But if it is only a UI issue, or if it's a wording issue or cosmetic issue, we call low. Basically, we have critical or showstopper, major or high, minor or medium, and low. Four different types of functional defects. And these functional defects we can prioritize based on the priority. Some critical defects not required to fix urgent, because think there is a critical defect in admin module. Admin module is not going to expose to the client. It is only internal application. Then it might not fixed immediately. But some UI defect, the wording defect, the label is wrong. It's giving the incorrect meaning. Though it's a low defect, you have to fix it immediately. Then it's a high priority because customer might mislead because incorrect label. Defect wise, functionality wise, it's very low, nothing to care about it. But user perspective is very crucial and priority is high. So some critical defects priority might be get low, some low defects sometimes priority might be a very high as well. So those two will have the as a characteristics of defect. So defects are the crucial thing in the life testing life cycle, right? We have to manage defects via the Jira or different testing tools. So these are very important. Reporting defects is very important. Okay. I think that's all from this immediate session I need to cover. So do you have any more questions? So we have 5 minutes to answer. Any more questions? Any more things to discuss? I think I answered the questions raised to me. I think let me go back again and see. So I think there was a positive testing part. Yes, positive, not only positive, we need to do the negatives. That's why I showed the not the decision table, state transition diagram, so how we have identified the other parts. Yeah, I think we can share this. Is okay. The new question: is there a way to decide whether to use manual testing or okay? I think that's a good thing. So I think that part we will cover part of our automation as well. So basically, manual testing is something actually dying, right? So the manual people not will much looked at manual testing, but it's still required. Basically, why manual testing is dying is manual testing is time cost, right? Time if it's required many times. So if you are trying think if 90, if that's why the 90,000 test cases took many months to execute because it's need large teams and execute and it's not work. That because of that we automate. If it's a complex system, obviously we have to automate because testing has to not to be done one time. If it's a one time, then you can do the manual. But there will be multiple releases coming, patch releases coming, defect fixes coming, multiple enhancers will come, and these softwares will run for 3, 4 years continuously, and there are multiple maintenance cycles coming in to run the entire test suite over and over and over and again. You need huge effort. So then you have to automate. So because of that, automation is a must, especially in agile we have to do. But manual testing might require, that's what I mentioned as experience based testing, like exploratory testing. There are experienced people can do set of manual testing and identify that automation suits can't identify. Still manual touch is required, but it's very minimum, very small effort. And experienced people, not the juniors or freshers. So ideally, you can identify it if you have multiple execution cycles, multiple releases coming on, defect fixes time, free releases coming on. Then, if you have multiple execution cycles, then you have to automate. Not then unless it's not work. If it's only one time, then you can go with the manual testing. But there won't be any release unless we develop for our project for a university or education. Rest in what we are developing live will comes with multiple releases. Right? So that's why we have to talk. Any more questions or anything? Yeah, test cases is more must. So that's again debate. So basically, test cases is must, but we can decide how to write test cases with less time consumed, right? So maybe you can write test cases like quick, straightforward scenario, or either you can build your own mind map and make sure. But test cases required because it should be scientific, right? You should know what are the requirements you tested, which code against you have tested. So if you don't have a document, it depends on tester's experience, right? So we don't know what he has tested. Because of that, we should have evidence what he has tested correct or not. Because of the test cases must, but if you don't have enough time, then you can figure it out your own way of writing a lightweight test cases. I'm not saying you should put huge effort, but now with the AI, I think that's what I'm going to discuss. That right, test case writing is nothing, very simple. If previously you took many days to write test case, now you can generate your test case within 2 seconds. So no need to put large effort now, right? So I'm not seeing now none of organizations are putting effort for test cases because it's very straightforward, but it's must. No excuse, you have to do. Any more questions? Hope that we wind up session. I think I can show it. Somebody's asked whether you can show it. Yeah, there's nothing, but you try it your own, right? Go to get the chat GTP, get a small business user story, right? So, and type it, give a multiple prompts. You can type your prompt with various way and give it to ChatGPT and he will generate test cases various way. When your prompt is getting changed, you will get a different test case. Right? So that's how it is. You can use many tools. I don't know whether people organizations will allow to use ChatGPT, but there are tools like Copilots and many other tools, proprietary tools to generate. Right? So simple. Get the business user requirement, just give it as a prompt. You will get all the test cases. Try it in ChatGPT. I'm not asking any chief engineers to write test cases now. I always I ask use some GTP model and generate why we utilizing our effort to write this kind of thing. No point since the tools are there. Okay, good. Any more questions? Unless I think we can. So next session we will conduct by Chaturanga, and before that we have a small quiz. Just scan the QR code and get this quiz and try it out to make sure you uh, learn during the session. Correct. You can. This is not a. I'm not going to score or assignment. This is just to validate what you have scan. You can just scan the QR code, and anyway I will share the link. So it's okay.
Thank you, Mr. Kapila. I think Chaturanga is already here. Maybe you can pass
Yes,
on.
yes, Chaturanga. I think you can start your part. Shall we stop this recording and start a new one? That's it will be easy, right?
Yeah,
Unless it
sure.
takes
So,
large time.
yeah, that's
Yeah.
right. So shall we make maybe we can make Chaturanga the host
Yes,
and
yes,
we'll
yes.
thank you, Mr. Kapila. It was a very informative session. I believe